Welcome to the May session of tinyML Trailblazers series. We are very excited to have a special guest today. It's Kishore Manghnani. He is a co-founder and current CEO of Shoreline IoT. Kishore is an industry veteran. He's done quite a bit of work in the semiconductor and space, and now he's one of the pioneers in tinyML, and we are very fortunate to have him here today, not just because of the tinyML background, but also because Kishore and Shoreline IoT are one of the several tinyML successful companies who really have tons of experience, not just in developing tinyML solutions, but also developing and deploying the whole products for different industries. And I hope that's what he's going to be sharing with us today. The idea of the series, as you know, is to inspire, educate, and illuminate, and that's why we are bringing these high caliber people to the global tinyML community to share their experience and their vision in this space. So before we start, as usual, it is my pleasure and a privilege to acknowledge tinyML strategic partners: AZIP, Analog Device, Adrena, ARM, BrainChip, Edge Impulse, Greenwave Technologies, Grovity, Inc., IBM, Imagimob, Infineon, Inotera, Microsoft, Nota.ai, NXP, Pollen Technology, Kixo, Qualcomm, Renaissance, Schneider Electric, SenseML, Sony, Silicon Labs, ST Microelectronics, Synaptics, and Syntient. As you know, one of the strengths of tinyML is our communities. So you can join these communities. They keep growing. On LinkedIn, close to 15,000 members in, actually not on LinkedIn, on meetups, 15,000 members in 39 countries, and around 16,000 people on LinkedIn. There's quite a bit of discussion and information and resources. You can find them. This presentation will be, this discussion will be recorded. You can subscribe to the tinyML YouTube channel. It's YouTube/tinyML. This channel has tons of resources also, close to 10,000 subscribers, over 500 videos with quite a bit of views. And again, this video will be posted there also this week for people to watch. We are super excited about this upcoming in-person event. I think we've been doing in-person events since last year. So this one will be in Europe, Middle East, and Africa. The physical location will be in Amsterdam. It will take place in about a month, a little bit less than a month. Registration and program are open. Just go to the tinyml.org website and you'll see all information there. It's a very exciting program, really, and the objective of this event is to grow and unify tinyML community in the Europe, Middle East, and Africa region. So super excited about this event. At this point, it is my pleasure to make an introduction of our host. Although our host, Dr. Chris Rowen, he does not need to be introduced to this community. He is super well known in this community from the very beginning, and even before tinyML, he was very well known in the semiconductor world, in the startup world. He's done a lot of successful startups in his professional life, and he keeps doing this, keeps innovating, keeps leading this industry. One of the big ones, obviously, is Tensilica, which is very well-known IP provider now. He was a co-founder and then a CTO there. And most recently, in the tinyML space, it was Bubble Labs, which was acquired by Cisco, where Chris is a vice president now in charge of AI, M&A, and machine learning. And he has tons of recognitions in the community. He was named as INSPIRE-EDUCATE Fellow and many other recognitions. And really, the pleasure is ours to have Chris here. And Chris, take it over.
Well, thank you very much. what's really exciting is to have Kishore here. Kishore Manghnani is the co-founder and CEO of Shoreline IoT, and he's been working across the semiconductor systems space for quite some time. And so it is, I think, a great opportunity for us to learn some more about Shoreline and to really understand what led to the creation of Shoreline, where is Shoreline now, and where is Shoreline going? Because I think it's a great indicator of what are some of the fundamental trends in both IoT and in tinyML. And looking at this intersection between this underlying computational model and the business and the applications of IoT should be very illuminating. So welcome, Kishore.
Thank you, Chris, and thanks, Evgeny, for inviting Shoreline. And it's my pleasure to be on this call and talk to the tinyML community. We're really excited.
Right. I think the place to start is the backstory. How did you come to lead Shoreline? Where did Shoreline come from? How did you get here? And how does that set the stage?
Sure, yeah, good question in this. We started, this was when I was working at Marvell. I was running the IoT business unit, and one of my customers was the Google IoT group. And that's where I met our CTO and co-founder, Mark Stubbs. And he's a genius guy. He worked at Apple before, at Google. And we used to, meet for lunch. And one day we said, why don't we start our own IoT company? And that's how it started. We didn't have a business plan. All we knew was we were going to do something with IoT, something with AI, and we spent one full year just looking at different market segments, from consumer IoT to commercial to industrial. And to quickly wrap this up is we realized we couldn't make money in consumer segment, even though both Mark and I had a lot of experience in that area. Mm-hmm. From his Google, Apple, and my Marvell days. Yeah. And then commercial segment, there was a market for IoT, but it just wasn't clear how much customers will really pay or how. But when we look at the industrial, which we were the least familiar with, but when we saw a big problem there, and that's when we say, you know what, even though we don't know as much about the space, but the problem looks so challenging and also so large, well, let's just jump in. And we learned a lot, but it took us a year to make that decision. And that was end of 2018. And in 2019, we started working on ML and the edge. And that's how we got involved with tinyML at that point.
Yeah. So what was the most motivating single problem that you saw back in 2018? What symbolized the opportunity for you?
Sure. So interesting. When we looked at the industrial customers, which includes manufacturing, energy, all broadly these like a sub-verticals within the industrial. There's roughly 100 million machines we saw globally out there, and about 18 million in the US alone. And what we were surprised to learn that 90% or more of those machines were still being manually inspected by people going out on a route once a week, once a month, depending on how critical that machine is, with the sensor probes, gathering data, emailing to some analyst on the PC, and then making phone calls with the reports. Mm-hmm. And they were spending few $1,000s per year per machine just doing all this manually. And the remaining 10% machines, which were well instrumented and monitored, the solutions were so expensive, they couldn't afford to put on 90% machine. And that's when we said, Mark's idea was, what if we made something very simple and scalable, affordable, like the consumer world, bring that experience, but make it for industrial world that people don't have to do this manually. And that was, so the problem was big. And for Mark, it was challenging technically, even though industrial machines are much harder to deal with than your home devices. And the the regulatory requirement, the wireless, you know, environment is very difficult in those situations. So it was very exciting thing to work on, big problem, but was very difficult to solve. And it took us 3 years to solve the problem.
Yeah. Now, there are two distinct dimensions of that problem. There's a whole set of problems which are local to a specific instantiation of a sensor package at a node out at some remote location. And it has to do with power and wireless connectivity and
Correct.
what sensors you have and what onboard processing you need to do.
Correct.
And there's a really rather separate problem of, okay, I've got a million streams coming into the cloud. How do I, turn raw data into some kind of intelligence? What's your role in those two pieces? What do you actually offer at the edge, and what do you actually offer in terms of the cloud environment that allows people to get insights from raw data?
Sure. No, yeah. So, I think you're pointing to what, when we started, one decision was made, we never changed that decision from day one, was to deliver an end-to-end solution. Just delivering edge only, delivering analytics only, delivering cloud only was not sufficient, because our end user was a field technician, machine operator. So what we decided to build the system, as you said, there was an edge piece in which we do sensing. So smart sensing, which includes multiple sensors, which are non-invasive, they could be mounted easily. And we put 3 processors in that sensor and running on a battery and running with the cellular connectivity, which is NB-IoT, ultra long range cellular connectivity, or the Cat-M, and to do edge processing, gather all the data, vibration, temperature, humidity, sound, ultrasound, analyzing all that right at the edge, looking for some anomaly. And if there's an anomaly, then you send the anomalous data, the raw data, to the cloud. And if there's no anomaly, you keep the data and send it in a batch with all the sensors. So that's where we use the tinyML, so we could, every 5 minutes or every 10 minutes, we can actually analyze the data and look for an anomaly, and then send the data to the cloud, so we get a longer battery life. Without tinyML, I can tell you our battery life would have been 2 weeks or 3 weeks. Yeah. Right now, we have a 3 to 5 year battery life with our sensor, because we don't send data all the time. We don't send all the data. We curate the data right in the sensor, analyze it. And so think of this way, we do anomaly detection in the sensor, looking at multiple sensor data. Once the data goes in the cloud, we look at the entire powertrain. Powertrain means a pump and a motor is a powertrain, a compressor and an engine is the powertrain. You could have 4 or 10 sensors for the entire powertrain. So we look at the signatures that we gather, the data from all the sensors in the powertrain in the cloud. And when we do classification in the cloud, you cannot do that in the edge. You don't have enough compute power. And in the cloud, we look at the long-term trends, how the baseline of the machine is changing over time, because some of the alarms are triggered based on how the baseline has changed over time. So all that heavy lifting is done in the cloud. So this is how the partitioning is for the intelligence locally and intelligence in the cloud, and keeping the overall solution affordable by having, you don't need to bring wires to the solution, keep it easy to install, easy to configure, and also provide a lot of value and insights from alerts coming from the cloud to the customer.
Right. Now, one of the challenges of creating the end-to-end solution is that you really get drawn into understanding perhaps your customer's business, your customer's exact needs. You can't say, well, here's my generic end-to-end solution. It's an oxymoron. And therefore, how do you approach the question of adapting that analysis to the way your customer needs to understand the data in the context of their operation? because that can be very unique to their situation.
Correct. Yeah, it's a very good question. When we started, I'll tell you frankly, we didn't know. If you look at our solution, it solves three big problems. One is the IoT part of the problem. How do you get data easily from an end user who's not even an IT person? Okay,
Yeah.
make the IoT part easy in a difficult wireless and a technical environment. That was problem number one. That's what we attacked in the year one, and we used tinyML there. The second problem was, once you have, there are almost 10,000 different types of machines out there. Just there's so many types of compressors alone and different. So how do you know how many sensors to mount on a machine and where to mount them and what data to gather given the specific machine? So all that know-how, we didn't have it on day one. So we actually then found a great person who is our chief science officer now. And he had done this kind of work, all the physics modeling of all these machines for many years, hands-on experience and written books about it. He had already retired. We actually pulled him out of the retirement. He went to the same school as Mark. So they got along very well. And he's spending, after his retirement, 70 hours a week now working with our engineers, where we actually built an asset library of physics models, so all thousands of machines already in our cloud. So this is what we call
a great model of retirement or a terrible model of retirement.
No, he loves it. I mean, this is he wrote books about predictive maintenance, but finally we brought the IT technology where his vision could be implemented.
Yeah.
So what we call this is industrial domain expertise. So we had to actually have that expertise in-house. Otherwise, you're not offering a solution to the customer. So that's how we learned what problem customer has, what we need to solve it. So that was the second problem we addressed, and took us another 2 years just doing that. The third problem was, now you have physics model, you can auto-configure the machines, the sensors, and you can download the physics model to the sensor. The third point is, now you have data, and if you want to do a long-term machine learning, if you ask a client for historical data, you need a lot of army of consultants to come in, label the data, curate. It becomes very expensive. So we had to build a self-learning system in the cloud for ML that we don't have to ask customer for historical data. We don't have to ask customer for even bringing their own network or IT network. So these are three problems we have to solve. But in the process, going back to your question, we learned a lot about how these customers work, what problems they have, and how we address them. And one decision we made is, instead of trying to sell through some intermediate OEM or resellers, we went straight to the end customer in those plants, in those factories, so we can learn exactly what's going on and validate our platform.
To what extent do you have to deal with the idea of fully integrating your analytics into their other operations systems? So, it isn't just, I can predict what machine is going out. They've got some higher level operation, software environment and operating style. What do you do at that highest level to enable them to integrate, or to integrate for them into those higher level systems?
So the way we design our cloud is, even though we offer the end-to-end solution, we build from day one the API interfaces to connect to the third-party work order system, whether they're from IBM Maximo, SAP, or other companies. We also build an API interface or connectors in our cloud to exchange data with the historians. OSI Pi is very popularly used by the energy customers or their other historians. And then some of them use a plant level analytics software packages. So or they have their corporate license for BI tools. So we build API connectors to those. So we provide complete solution, analytics, alarms, but then we we exchange data with all the enterprise ecosystem, because that's very important. Otherwise, not everybody in the enterprise can see the value from our solution.
Yeah, I find that area fascinating, but this audience really loves the hardware. So tell us some more about, what is it that you're actually installing? What is the thing that happens, that gets strapped onto, bolted onto a compressor and motor?
Sure. So let me show you, actually. I have it right here. So this is an iPhone mini in my hand. So you can see the relative size. This is the sensor. It's 1 inch thick and shorter in height, 1 inch shorter than the iPhone mini. And if you look at the sensor, it's all certified for FCC, all the hazardous location to go in oil and gas, and all on those pipelines, and all those certifications are done. What's inside this sensor is there's 6 different sensors. So there's a sensor module, which has a ultra high resolution triaxial vibration sensor. It has a sound and ultrasound sensor. It has a ambient temperature and a surface temperature sensors, and has a humidity sensor. So there's 6 sensors built inside. Then you have Bluetooth long range. You have 2 cellular radios long range, all built inside. And then obviously you have MCUs and to run all the tinyML. So there's a dedicated MCU to run tinyML and all gather the sensor data. And then we also have, if I'm pointing here, there's a input port, which is a digital and analog I/O. So if a customer has any other industrial sensor like flow rate, gas pressure sensor, CO2 sensor, methane sensor, they can just plug right into here, and we will analyze data from external sensor as well, bring it to cloud, displayed side by side to all the data gathered by this sensor, and analyze it all together in the cloud. So this is very unique, and the reason we ended up doing, 90% of our engineers are software engineers, and our business model is a SaaS business model, 100% subscription. We don't even sell the sensor, it comes with a subscription. But the reason we had to do this hardware ourselves is there was nothing like this existed, where you can run on a battery for many years. You could do, including cellular modem, 6 different sensors, multiple processors, and provision it with your smartphone, and go through all these security authentication. Most sensors out in the market are really dumb sensors that exist and spit out the raw data. So we had a background also to do, so we were comfortable. A lot of software companies are scared of touching hardware, but because we came from hardware background, we just built it, we designed it.
So let's talk about the tinyML angle here.
Sure.
What kind of models do you run? What kind of filtering are you doing at the device? What degree of autonomous detection or behavior do you build into that module?
Yeah. So what we have is in the module is we do 2 things. We do signal processing. We do FFT analysis as we get these vibration and ultrasound and sound signatures. And we also run a tinyML model. I don't have the specific details, or CTO can tell you exactly which model, but I know it takes about 50 kilobytes of memory there. And we look for anomalies. But the model is obviously first trained in the cloud and pushed down over the air to each sensor, depending on, and the weights could be updated as we get more and more data. So we build all the over-the-air upgrade model to update the weights, update the model, but we're looking for anomalies in terms of are there excess vibrations? Are there we can listen into, for example, one use case was, let me explain to you, in the oil and gas industry, especially with you have huge compressors compressing the natural gas and then pushing to the next booster station.
Mhm.
A lot of methane actually leaks from those compressors when there's a leakage, when there's some, the packing is compromised. Because of the ultrasonic sensor we have and because of the model we built and we push down the sensor, we can listen to if there's a leakage happening in the compressor and then send an alert to the station owner, look, your gas is leaking, you should send somebody to fix the leak. Go ahead, Chris.
Yeah. So if I understand, you really are doing the modeling of what constitutes an anomaly in the cloud and downloading then the parameters that allow
Correct.
for detection of that anomaly in the model.
Correct. The inference is in the edge. Yeah, edge is doing the
Right. But you don't have to run the whole anomaly definition model at the edge. The anomaly definition comes from the cloud, and then you're just doing detection on a per node, but on a per node model. So you get this personalization of what is an anomaly, but you don't have to do all that kind of training or pseudo training there. So
correct. I think if we were to do that, then we'll be consuming a lot more battery at that point. And it's very important in this business that you provide multi-year battery life if you're doing any sensing. Otherwise, they have to put wired sensors that the cost goes up dramatically.
Yeah, right. So how widely used has this become? Can you say something about sort of how many nodes, order of magnitude, you have running there in the world?
Yeah. So to give you a timeline, so we did our very first prototype of this thing, which looks like a toy now, is back in 2019, we actually were working closely with the Google TensorFlow Lite micro team at that point, and they liked it so much that they actually showed it on the Mark, our CTO, was on the keynote and the TensorFlow World in 2019. That's when we first demonstrated the engineering prototype, I should say. It took us till the last year, first half of last year, we're doing pilots with the customers, industrial customers. The commercial deployment just started in July of last year. So we're not even in 12 months of our commercial deployment. So it's a very new product from that point of view. We have several thousand nodes already deployed in the field. And we focus in the year one on large enterprise customers, but some of them are listed on our website. So these are all major global brands. And we did a very good close partnership with AWS to just focus on large enterprise customers in the year one.
Yeah. And what at this stage are the factors that gate your growth? What, to what extent is it finding customers or building the hardware or doing the software integrations for different customers? What are the kind of the things you worry about in trying to figure out how you move up that growth curve? I'm sure you worry about all of it, but what do you?
No, you're right. I think the most of hardware work is done. There'll be future update on the hardware, but the heavy lift on the hardware is already done, is behind us. And also the heavy lift on having a cloud, which is multi-tenant, multi-user, all that piece is done. We're in deployment. What is the growth now is a big part of the growth is go-to-market, sales and marketing, because in the industrial world, it's not concentrated like a lot of the technology world. It's very fragmented. You have thousands of customers to go after, and then you have some channel partners you have to appoint. So how do you raise the awareness that such a great product and platform end-to-end exists for all these customers who are used to buying from legacy companies like Rockwell, Emerson, Honeywell, which are 10 to 20x more expensive than what we offer. All of them are not cloud-based. We are cloud-native from day one. So how do customers know this? So I think raising the market awareness, go-to-market, appointing the right channel partners, and then doing some customer directly. So the entire go-to-market is a big part of the growth plan for next few years. Okay,
right. Yeah.
That's number one.
It's really interesting because, the closer you are to the center of tech, the more people already fully have embraced cloud and SaaS and all of that as a major uplift to all these operations in making them more efficient and flexible and scalable. But you get out into the industrial segment, and people are just waking up to the tailwinds for their business that comes from going cloud. And so you do have some heavy lifting there.
Actually, I'll tell you, cloud is not an issue anymore, thanks to COVID, I'll tell you. We were talking to customers, we didn't have product ready before COVID. Almost 40-50% customers used to ask, oh, do you have a hybrid solution on-prem and cloud? Yeah. We don't get that question at all.
Okay.
All the new RFQs are cloud, they need cloud-based solutions. So that is gone. I mean, maybe some part of the world, they still ask for it. In US, Europe, it's completely gone. In fact, if you don't have cloud solutions, it's a negative now, even in the industrial world.
Okay, that's good. I'm really happy to hear that. So in every journey like the one that you've been on, there's usually more than one setback, more than one case where you made some assumptions, you did some work, you got to a certain point and you said, we're going to have to change direction. Either we need to change technology or business model or people or customer targets. What was that for Shoreline in that history of places where you needed to recognize that some important new direction needed to happen?
Yeah, and I think there's some things that, and I'll say there are probably many things that change, and something didn't change. And let me start with something that didn't change and something that changed. Let me give both here. Something didn't change is the vision that our CTO had, Mark, was we're going to make it simple and affordable to extract data from millions of machines and extract the value and make it affordable, scalable. Mark had this thing. He's not going to ship a product with any manual because all the industrial products are shipped with 100, 200 pages manual. He said, coming from Apple, Google background. So I negotiated with him. There's going to be at least 1-page instruction manual for the installer. And that's all we do. There's everything driven by software. That point that it's a product designed by engineers for non-engineers. Right. That thing has not changed. Make it simple, affordable. Right. And there were times where we were thinking, oh, it would be faster if we just didn't deal with that pain. And Mark was, no, we're not going to even build a company unless we can do it. Okay. Yeah. So I think that part has not changed from day one.
Yeah.
What changed was, as we learned about, industrial has many sub-verticals, whether it's chemicals or discrete manufacturing, oil and gas, or pharma. So we had to so we were focused initially some on chemicals. We learned opportunities were actually bigger, larger in discrete manufacturing and oil and gas and pharma. So we had to change the vertical segment we focus on. Mm-hmm. Which had to fine-tune our go-to-market strategy. We learned we couldn't do so many customers direct, so we had to find the right channel partners who can support the customers. So those things had to change. On the technical front, one bet we made, which we were not sure, I'll tell you. We wanted to make the initial provisioning and connectivity so easy that the person doesn't even have to go to IT department for approval. Because in this company, it takes you 4 months just to do a pilot to get approval for the pilot with the IT department. Yeah. So we put ultra long range, these NB-IoT cellular modem from Qualcomm in there. And we were not sure what the coverage was until we do the deployment. Right. It's such a new thing. I'll tell you, we're lucky that in the US, we have not found a single spot today in remote locations where we don't get the coverage. So we have a coverage, which is amazing. I think it's a secret that a lot of people don't know. they still think, well, the coverage is not there. In the US, it's everywhere. But technically, a lot of things change. I mean, I'll tell you, on this hardware, we went through 4 or 5 different iterations till we got the right battery power. So those things change. There were cloud architecture. We ended up doing a certain architecture when we started. Then we moved to serverless architecture. So we had to almost redo our entire cloud architecture after 2 years. So almost like the first 2 years of cloud architecture development just changed.
Got it. So what's next? What are the next big targets? What, and think both technically and in business terms. What is the set of challenges or opportunities that you're salivating for, that you're looking forward to?
You're talking technically or business-wise?
Either one.
Okay. So on the technical side, if you have any product that has AI ML, the very first question customers ask you is, "Oh, what are you doing with generative AI?" So, I mean, it's a question you get all, just last 3 months, we're getting that question all the time. So I'll tell you, I won't go into details what we're doing, but we were fortunate that we were using GPT already since second half of last year. We're doing some kind of internal POC development. The main reason, if you look at the data we get, people think from machine health data we get is like all the data you get, vibration, temperature, all that. But a lot of data from the technicians is all in text. What's wrong, what repair they did, what didn't work. There's a bunch of history there that we have. And we were looking at GPT. How do we take data that is, like a mathematical format, and the data is all in text format and mixed? And you need that learning in the system to have the feedback into the AI. But in some sense, so we're doing work in GPT area. We have 2 use cases we identified with customers. We'll be rolling those out later this year. But we were lucky that we were already doing something, and it was in the development stage, but still we were experimenting with it. So that's the new thing on the technical side, I would say. And on the business side it's mainly going international after the US. We have focused more on the US market. There's a lot of opportunities overseas. We just haven't tapped. It's just early stage of a company.
Yeah, right. Oh, I'm sure. It sounds like the breadth of applicability is enough that even if you were limited to North America, you could do a lot of business.
Correct. No, you're right. And we're doing a vertical solution for asset performance management, predictive maintenance for these machines. The machines a compressor looks a bit different in a oil and gas location than a manufacturing site. But the way we design the models, we can adopt from one subvertical to another subvertical. It's more, you have more business development effort rather than the technical effort to go from one vertical to another vertical. Yeah. So there are many verticals we have a kind of over the next few years with the same platform, same solution. We don't have to build a new sensors, and everything is software defined. Even the personality of the sensor changes depending on which machine you put this on.
Got it.
So architecturally, we make sure we can tap different segments over time. It's more business work to go after each segment.
Yeah, right. I imagine. We're starting to get a number of questions coming in, so I think it's time to pivot to some of these questions. Andrew asks, do you detect plant-wide anomalies? For example, if node 1 detects something and node 2 further down the line detects something, can that trigger an anomaly? Or is it only on a per node, per sensor stream analysis that you typically trigger?
No, we actually, in the cloud, we look at the entire either powertrain or entire system. We don't just look at per node. But at the node level, we only look at the node level. There's not enough compute power
Right.
or storage in each node. But in the cloud, we always, the predictive analytics anomaly detection is always at the powertrain or the system level.
Yeah. Anonymous asks, how are you different from Everactive in the industrial segment? I don't know who Everactive is, so is this somebody who shows up in your space regularly?
No more. Last my understanding was, I think they're either closing or selling. So we are very different in a sense. Everactive started as a chip company, and they were doing energy harvesting chip. And then to look for the application, my understanding is they built a vibration sensor. They didn't have the cloud. They didn't with the complete analytics. So they're building pieces of the solution every time, over time, and starting from chip design. As you know, Chris, I'm from chip space. You're there for chip space. It's not easy to build your own chip and build the system solution.
Yeah,
it costs a lot of money. It's you either do one or the other. You cannot do both. I mean, unless you're Google or Apple, you can do your own chip and own system.
And even then, it's hard to do it all. Maybe Apple can do it, but even a little smaller than Apple, it gets very difficult.
Correct. So I think, so Everactive just had a piece of the solution, and
there's a question from Sumat. Is there a particular vertical where you focus? To what extent do you really cover any industrial segment?
Yeah, so we focus on, there are many sub-verticals within industrial, like automotive is a big vertical itself by itself. And so we focus on energy, discrete manufacturing, like appliance manufacturing, and pharma. So these are three sub-verticals we're focused right now, and that's plenty for us at this point. And there are three additional ones we can go after in the next few years as we grow. But energy, pharma, and the discrete manufacturing.
Yeah. Dale asks a question about effectively closed loop automated responses. To what extent do you expect and handle cases where the detection of some event leads to some automated response, which you then are involved in managing in some fashion? Or is it really just the data collection without an assumption that there's some closed loop behavior from your sensor?
So actually, that's a good question. By design, we chose not to do the control loop ourselves. It required a lot of safety and other requirements and regulatory requirements. So we do remote machine monitoring and do predictions and diagnostics, all that. And then we send alerts, alarms to the end user. They can then choose to take action on their own, either manually, or they can turn on some knob or remotely. It's up to them. Our platform, by design, we do not do that. It's for a startup to get. This is where legacy industrial guys have spent years getting all those safety certifications and other stuff that we didn't want to get into. We decided to stay away from that.
Yeah, that makes a lot of sense. Oscar asks, in addition to natural gas compressor leak detection, what are the most exciting use cases of audio or ultrasound sensing that you've seen?
Yeah, this is something I know Mark, our CTO, will be able to answer quite a few examples of this. I'm just thinking as we go through. Maybe let's go to the next question, and I'm sure I'll remember them.
Yeah. How do you assess safety aspects? Have you seen situations where the AI models don't demonstrate common sense? And to what extent? Fortunately, you're not doing closed loop control. So you're really passive, but you're still involved in safety aspects. And I think that's both what do you do technically and what do you do in terms of regulatory compliance in order to sort of stay on top of the requirements, even for the passive sensing role.
So I think the passive sensing role, there's no regulatory requirement as to say,
Okay.
unlike in the control area, there are specifications. If you want a certain kind of machine, there are industry standards, what kind of measurements you should take, and if certain thresholds are crossed, then you should trigger an alarm or it's considered an alarm. So we follow all those standards which are for the industrial segment for class of machines we deal with. So all those are already covered in our software and the models. And to go back on the AI side, this is one of the learning we had initially when we got the data in the cloud before we had the physics models of the machine. Like any other data scientist, we said, oh, good, we got all this data, let's analyze, and we're trying to do prediction. And we were 30 to 40% of the time, we were wrong. Our predictions were wrong because there was no domain expertise. You're just looking at data as a data, and there's no expert knowledge.
Yeah.
So that's when we got Keith, our chief science officer, on board. We built physics model. And so we took a hybrid approach. So this physics model act as a guardrail for any AI ML predictions. It's without that, you're just doing a non-expert just data crunching, and it didn't work in our case.
You're taking some cloud of data points and drawing a line through it, saying, "Look at my insight."
Correct. No, so this was the question you asked earlier. What things we learned? This was we learned in the second year. Hey, we're going to go nowhere with this one. We're just going to be a company providing IoT solution. Here's the data, and then customer has to spend millions of dollars trying to do the rest of it themselves.
Yeah, here's a fire hose of nonsense. Yeah. Thank you very much. Yeah.
Or you bring a lot of experts to curate data, analyze all the time, then it gets very expensive. And so that would have defeated the whole purpose of starting Shoreline, to make it scalable and affordable.
Right.
So the physics model was this answer to make it in do a built-in domain expert in your software.
Right. So are there any things you see in terms of changes in the problems that customers need to solve that will drive you in new directions, either new kinds of equipment that's being installed that represents opportunity, or new kinds of integrations that they need to do with the rest of their plant control or business intelligence kinds of things that will force you to really rethink this. I mean, I think you mentioned an interesting case with using GPT, because you get this mixture of technical data and human data that you have to analyze, and that's kind of a significant opportunity or challenge there. What else falls in that category of things coming up over the horizon in business or technology that you need to anticipate or be ready for?
Yeah, so I think, and some of those things we get pulled into by customers. Oh, can you do that? Can you do that? And the area we're seeing, we get a lot of interest is, can you help us do energy savings? Because now we have so much data about the machine. Can you tell us, can we reduce the energy consumption? Because if you look at the industrial companies, energy is a major cost of their total cost of goods sold. Unlike commercial buildings or residential buildings, the largest users of energy is the industrial world. Whether they're consuming natural gas burning or they're using electricity or whatever. So any improvement you help, even if you improve their 5 to 10% energy, that's a direct impact on their gross margins.
Yeah.
So we're getting a lot of requests now, and we're with some customers. We're already doing pilots where they use the platform, our data platform, our cloud platform. Now we're analyzing data where we can say, oh, you can change these settings in your machine and you get to run, you can save this much in the energy cost. So that's one area we're getting pulled into. The second one is as you mentioned, integration with other business intelligence, corporate system. It is from day one, we took a platform approach to be able to integrate with other systems, let other people integrate. Most of solutions out there today are point solutions. So we stayed away from point solutions. So that's another area of growth. GPT, I think for us at this point, there's plenty, I'll tell you.
Yeah, right.
to handle. Yeah.
Well, we're getting towards the end here. Let me check and see if we have new questions. Sumat asks, I'm assuming there's no computer vision sensing at the moment in your device. Is there a way to synergistically work with vision sensors in the environment to expand monitoring for safety, productivity, cost savings? Or are there plans to remain focused on kind of the machine predictive maintenance and performance using what's arguably low bandwidth sensors? You know, a microphone is the highest bandwidth sensor run. So what about new sensing modalities like cameras?
Okay. No, actually, we have looked into this. We have not developed anything. We have the computer vision experts in our team itself, but we have not done anything there. But there's definitely use case for augmenting with the vision with sensors for some very high resolution, the video sensors. We have some very cool ideas that if we can get a low cost, very high resolution, VGA, but a lot more frames per second, then that's what's available in the market, that some additional things could be diagnosed. But it's something we'll have to partner with somebody to do it. It's heavy lift on our own.
Right.
But there's definitely good use cases for adding vision.
Yeah. Well, that also has a impact on the computational resources, because you bring in a sensor like that, you surely don't want to send raw video to the cloud. And so you're going to have to do considerable reduction based on, events or higher level representation of the data. And that may drive your MCU requirements to something orders of magnitude better. Because I imagine that the algorithms you run today don't necessarily push the envelope of your computational resources yet.
No, you're right. It is going to require a complete new hardware. Even connectivity would change, or maybe you do a lot more analytics at the edge that you're not sending as much data. But and then if it's looking at the entire system, and then if you have, there's definitely value there, but it's almost like a startup by itself, another startup, frankly.
Yeah. So I want to finish with one last question.
Sure.
What question should I have asked? What else do you want to mention to kind of leave the right impression of what you've accomplished and what other practitioners in the tinyML world should take away from your experience?
Yeah, I think the question could be, I think the thing we also did ask ourselves when we started, we knew AI, we knew IoT, we jumped in, and took us 1 year to figure out the segment, another year or two to figure out what things we have to change. So I would say whatever know-how you have, definitely that's your core strength you want to start. But before you go put a lot of money into it, definitely look at what is the end problem you're solving, what else you're going to need to get there, and either get the right people in your founding team who have that expertise to fill in the gap, or find the right partner ecosystem early in the process. We had to build those additional things over time as we learned. But sometimes you don't have luxury, so it's better to, as much as you could do early. I would highly recommend that.
Great. Well, I think you've asked and answered the question. And I want to thank you for a great hour chatting about what you and Mark have done and about Shoreline.
No, thank you, Chris, and thank you, Evgeny. Really enjoyed this conversation, and Mark, Keith, other co-founder Vinayak, and the team is done a great job. And through the COVID, that was one of the challenges. The best part was we were, with COVID, we were wondering, what's going to happen, but it literally forced us to build our solution, self-install, do it remotely without us going, and make it scalable. So there was a positive side that came out of. We were planning to do that, but we were forced to do that. That's what changed.
Right. Well, with that, I hand it back to Evgeny. He always has a closing question.
Sure. Oh, yeah, sure.
Be prepared. But before that, thank you, Kishore. Thank you, Chris. It's been really a very pragmatic yet very inspiring discussion. I really enjoyed it and learned quite a bit. I'm sure the audience learned also quite a bit, like how to do end-to-end, how do you build physical models, just not relying on AI only solving your own problems. You still need to have kind of people and physics in the loop to make it robust. I think it's been great. So before we conclude, Kishore, I have my favorite question. You had been a successful executive before Shoreline IoT, and now with Shoreline, you're a very successful entrepreneur. So kind of personally, what does it mean for you, success?
Oh, well, I wouldn't say we're successful yet. I mean, we're just in the first year of our commercial deployment journey in a market segment that we're still learning about the end customer buying behavior. So, I mean, I would say we're in the second innings right now. We got 7, so many more to go.
But you're too modest, Kishore. I think you are. But like, what does it mean for you personally?
I think personally, we love to see millions of machines being handled this way. That will give us the most personal satisfaction. And Mark and I mean, one thing I didn't mention, both I had retired when I turned 50 and when I left Marvell for a year, and then I called Mark after a year, and then we decided we came back. So not only we pulled Keith out of retirement, we pulled ourselves. We're doing this for fun, frankly, I'll tell you, in the sense, both we will get satisfaction when this thing gets deployed, widely used, and it just changes everything, how they run their business. It's not just the technology. How they run their business changes.
So basically, for you to be successful, just to see your mission accomplished, right? That's like you and Marcus had it from the very beginning, and you guys driving towards this. That's great. I'm sure you'll get there soon. Well, thank you again, Kishore. Thank you, Chris. It's been amazing. And just at the end, again, let me acknowledge our strategic partners shown here. So they are Executive Edge Impulse, Qualcomm, Sentient, Platinum Renaissance, Sony, and then we have in the gold bucket, we have Analog, Adreno, ARM, Infineon, Innoterra, Microsoft, SensiML, ST Microelectronics, Synaptics, and the silver sponsors are here. And we look forward to seeing you in a month. And thank you again.